All right, folks, thanks so much for making your way back in. We're going to have our next talk up here. Going to start out with Jack Pierce, one of our intrepid solutions architects here at DigitalOcean. He's going to be talking about how to build trusted agents on DigitalOcean. So welcome, Jack. Please come on up.
Thanks, Darren. Hey, everybody. My name is Jack Pierce. I'm a solutions architect at DigitalOcean. I've been with DO for about 3 years. So I focus on helping customers to build scalable solutions on DO's cloud. And I'll also be inviting Hovset from Lorvo onto the stage. He'll be talking about how his company have built agents in the legal sector. So in this session, we will explore what is the Gradient AI platform. We'll look at some issues that cause you to lose trust in your agents. And we'll look at some of the observability tools that DigitalOcean have built so that we can regain trust in those agents. We'll explore some real-world use cases, internal use cases at DO, and then we'll take a look at the customer case study from Hovset. So the Gradient AI platform, what is it? It's a platform where you can build agents with the ability to use guardrails, functions, multiple models, knowledge base, all built in. There's no building and deploying infrastructure, and everything that you see today in my demos, there is an API available for developer-first approach as well. Not only that, the platform supports sub-agents, so you can route your queries to multiple agents depending on the nature of the query. So some models better for certain things than others. And the best part is that you can do this in minutes. So you can get started with the platform, you can have an agent up and running in minutes. So what does that look like? So I feel like it's important to just have a visual of how easy the platform is to use. So there's a demo going to run now. So this is the Cloud Console, and we're going to create an agent. So we come in here now, and we need to give our agent a name. And then we set our agent instructions. This is our system instructions that will pass to the language model. We then select a model. So selecting a model is very, very simple, and we can choose and we can change this model later on in the process. For each update that we make to our agent, we have an agent history, like a git commit history. We have open weight and frontier models available on the platform. So we've created our agent. Now we just attach our knowledge base. So our knowledge base gives our agent context, a number of data sources that we can choose, S3. We can just do basic file upload. We can do web scraping. And this knowledge base is an OpenSearch, fully managed OpenSearch database. So we create that managed OpenSearch database for you, but you can also use that for other purposes as well. We take your data and we create vector embeddings. So you can see here we're selecting which embedding model to use, and our documentation, which is available throughout the creation process, gives you best practices, tells you which embedding model is better for certain purposes, and how many parameters. We then have this table available, which will give us an indication of how big your data will be once it's been vectorized, and the cost to index that data. So it's really simple, really easy to understand how much this is going to cost, how much data is going to be used, and how much you'll need. And then we create that knowledge base. We'll attach that to our agent. We can come straight into the playground, where we can just ask our agent a question, and that's it. We're up and running. This agent is then available via an API endpoint, OpenAI compatible, or we can give you a JavaScript widget to embed on your website. But we're not here to talk about building the agent. That's seemingly the easy part. So what does scale mean today with an agent? So we take part of the infrastructure for you. We scale it for you. That's not a problem. But trust in your agents is a problem. So software is typically deterministic, and we write tests for that software. It's like a vending machine. You push the same button, you always get the same output. With a language model, they're inherently unpredictable. So you need to build trust with this agent that you've built. And we're going to talk through how you do that with DigitalOcean's observability tools. So for example, prompting. Prompting is tricky to get right. Your language model can follow your prompt precisely, and it still might not give you the answer that you desire. So we go in and we're constantly iterating on that prompt, but how do we then know whether or not those changes have worked across a large number of inputs? And the knowledge base. So your users will start to ask questions of your agent, and they might be asking ambiguous questions, or they might be asking very concise, clear questions. But if the knowledge base is out of date, then it doesn't matter how clear their question is, the response will be bad. And function calling. So the Gradient platform allows you to retrieve data from external sources. That's either your internal sources, databases, or information from the internet. Essentially, the language model is calling a tool, but how do we start to debug that? And how do we actually understand what went into the language model that then resulted in the output? How do we know it's not just hallucinating and that it actually called the function? So we begin to debug and understand these issues by using the observability tools that are built in to the Gradient platform. And by doing that, we can start to build trust in our agent, and then we can move it into production. And you can sit there and you can do individual testing on individual inputs, but you'll be there forever. How do we test our agents at scale? How do we get trust across hundreds and hundreds of different inputs? So these are our tools for trust. We've got conversation logs, traces, logstream insights, and evaluations. So let's take a look at those. So conversational logs is a message style view of all the interactions with your agents. You can come in here at any stage. You can take a look at every single interaction with your agent, and you can debug individual traces. You can see the input, the output, the context that went into the conversation, and then you can start to understand why your agent language model responded the way it did. So it's no longer a black box. You can actually understand what's happening. You can even inspect the knowledge sources as well. So you can see that going into the language model. So here's a quick demo of what that looks like. So this is the conversational view. We can do a full text search. We can also filter by date. So come in here and we'll do a search for Kubernetes. And we'll click on the messages view. We can see that trace in action. So you can come in here and you can click down into the individual traces beyond our message view. We can see the raw input. We can then see which part and which chunks of data were retrieved from the knowledge base. We can see how the different retrieval methods affected that knowledge retrieval as well. So you're no longer guessing, you can actually see it in action. Because sometimes just reading the documentation isn't enough. Sometimes you need to actually see it in action to understand. And what do you do next? Well, the next step is making sense of this information. So we have two tools for that. The first one is Logstream Insights. So Logstream Insights, it continuously monitors the conversations that are happening with your agent, and it analyzes whether or not it thinks the response was good or bad. How do we do that? So I'll talk about that in a second. Not only that, it doesn't just tell you that there's an issue, it gives you examples of that particular problem, and then it also gives you recommendations on how to fix it. You can also see how often this is happening. It might have just happened once. It could be happening a lot. The next tool is our evaluation, so it's our testing suite. And this is how we begin to benchmark our agents. You saw Phil showcase that earlier. We can set a metric that we can, and a number of different parameters that we can test against. And instead of manually spot checking answers from our agent, having to manually go through and benchmark this ourselves, we can run large data sets of prompts into the agent. It can churn through them, and then we get the output. So this kind of testing helps you to build trust, and you're not just hoping that the agent will behave, but you can actually prove it with data and testing results. So what does that look like? Well, I'll show you a demo in a second. We call it evaluations. We recommend that you start with 50 to 100 prompts. So these are questions that you would expect to be asked of your agent. And then we can start to see the responses. But we're not just inputting data and then looking at the results. We're actually telling it that we want to test against specific metrics. So what's the response quality? Are we testing for safety, instruction following? Are we checking that it's handling the tools correctly? Are we checking that it is referencing the knowledge-based data? So how do we build that? Well, it's language model inception. What do I mean by that? So we take the input into your agent. That includes the full context. And then we look at the output from the agent, and we send that to a frontier model. And that frontier model will evaluate whether it thinks the response was good or bad based on the metric that we're testing against. We then set a score, and the language model will give it a score. So one thing to call out here is that when we do this, we send the input and the output to a frontier model to analyze that data, and you're agreeing to share that data for the purposes of generating those recommendations, but it can be a very, very powerful way to level up your agent, especially when we're testing thousands and thousands of inputs. What does that look like? So here's a quick demo. We'll come into the evaluations and we'll create a test case. So an evaluation test case is a way of saying, I want to test my agent for any number of these qualities. So we can check for general hallucinations, prompt injection. We can check for instruction following. This is then how our language model knows and understands what it should be checking for. User goal progress. This is a good one. It checks the progress towards the goal that the user is trying to get to. And then we have a number of knowledge base metrics that we can check against. Is our language model just hallucinating, or is it retrieving data from the knowledge base in relevance to the question that's being asked of it? We can select multiple metrics that we're testing against, and then we select our star metric. How do we input this data? It's just a CSV. So we create a spreadsheet of questions. These queries, we can set any number of queries that we like, but we suggest starting with 50 to 100. We can also then set the expected response. You don't have to set this is optional, but this is just a natural language response that you would expect your agent to respond with in order to give the correct answer. So we attach that test data, and we create and run the evaluation. After we've run the evaluation, we can then come in and see an overall score for each metric that we tested against. And we can also see the individual prompts and the score that was given to the answer for those individual prompts. So what's really powerful here as well is that we're not just scoring each response. This language model that's performing these evaluations is given a full explanation as to why this is a bad answer. So retrieved context relevance, it's called 0%. It basically means that the information was not in the knowledge base. So it had no context here, apart from the information that's already part of the language model, which can be bad because it can be outdated and it causes hallucinations. So when we dig in further, we can see which parts of the knowledge base was used in the response. So there was something used here, but just not the right part. Or the knowledge base didn't actually contain the data. Again, for each metric, there's a full explanation as to why this was a bad response. So I want to talk very quickly about an internal use case at DigitalOcean. So the DigitalOcean people team, they received 6,000 tickets since 2023, and most of those questions are repetitive. A lot of the information can be found from internal knowledge base sources. These are things like payroll and policy clarifications, holiday clarifications. So we started to build an agent that can answer these queries. And we started to use the tools for observability to understand where there were gaps in our internal knowledge bases or where there was old information. And then we started to understand some of the bad responses that we were getting from the agent. And then we evaluate it time and time again, and we iterate over the prompt until we get to a point where we're very happy with the output. How did we do that? So we scraped Confluence and we imported that into a knowledge base. And we then have a Slack bridge to bridge our agent straight into Slack. So this allows our users to just open Slack and ask questions of the agent. They don't need to go to another website. They don't need to do anything they're not already used to doing. And they can just ask that agent questions and get that information straight into Slack. So we have code samples that we can share with you on how to easily get the gradient agents into Slack. Now I want to introduce Hovsep from Lorvo. He has flown from Canada, Toronto, to be here, and he's going to talk about how they're building agents in the legal sector.
Thank you, Jack. Good afternoon. I'm Hovsep Saraydaryan, co-founder and CTO of Lavo. Lavo is an AI-enabled Canadian legal tech platform that provides unlimited legal advice to businesses of all sizes. We use Gradient AI to deliver guidance and automation that is accurate, fast, and compliant. In regulated industries like finance, legal, and healthcare, even a small mistake from AI can create major problems. Reliability is not optional. The challenge is that most available large language models are great at giving fast answers, but those answers are most of the time outdated, not accurate, or legally irrelevant. They hallucinate. They lack jurisdictional awareness, and that makes them dangerous in high-stakes environments like legal. And business owners don't just want generic AI, they want trusted answers that they can act on with confidence. This is our solution. So Lavo was built on the Gradient AI platform with the multi-LLM strategy where we switch language models based on the subject matter. And it's layered with 200 private RAG knowledge bases that we built and adding every day. And those knowledge bases are enriched by our in-house lawyers. And we have a patented technology for ensuring kind of compliance and efficiency. And there's always like a lawyer in the loop, so everything that goes through the knowledge base is checked by lawyers, validated by lawyers, and they do the testing, so we have real life answers and not just AI generated content. Part of our platform is an AI co-pilot that we provide to our customers. And this is the process that the AI co-pilot runs through. So as a customer, whenever I ask a question to the AI co-pilot, it goes through a jurisdictional selection of their location and the legal subject matter. Then it goes through a prompt engineering process where we add some context to that question. We turn it from English to legalese almost. And then it goes through the guardrails that Gradient AI provides, which are the safety guardrails, the jailbreak guardrails, all those different layers of guardrails. And then the data, the query goes to the RAG. So every AI agent, which we have 144 of them right now, has access to multiple knowledge bases, and they pull the information from the knowledge base, and then we have case law knowledge bases where it kind of gets paired with the case law, and then at the end, the customer gets a jurisdiction-specific, accurate and compliant legal answer to their query. The tech stack. Our architecture is built for flexibility and compliance. As I mentioned, we use the multi-LLM setup, combining models from OpenAI, Gemini, and some open source models, all accessible through a single unified endpoint. We connect the private legal knowledge bases and documents like PDFs, Word files, and URLs. And our in-house research lawyers, they create harvest maps of legal sources of like government platforms and portals that always gets updated. So every regulation that comes out, it's already on our platform. And we maintain versioning, traceability, and we use the evaluation tools that Jack just showed, which is amazing. It's very needed in this space. So that helps us, track outputs, test changes, and keep performance consistent before even, we push anything live. On the platform side, as I mentioned, it's Gradient AI. It gives us serverless inference, model hosting, automatic scaling, all without the kind of the overhead of managing our own infrastructure. We also get unified billing, reporting, logging, all in one place, so we can track performance, usage, costs, which cost is a big deal for a startup like us, and using DigitalOcean and Gradient AI, we see a huge cost saving on that end. We actually did look into other platforms before using DigitalOcean, like we looked at AWS, Google Cloud, but the reason we went with DigitalOcean is because they have a Toronto-based cloud data center, and as a legal tech startup, our data has to stay in Canada, so that was a big selling point for us to go with DigitalOcean. In terms of validation and safety, it's critical for us because accuracy is key and it's non-negotiable. So we run the agent evaluation tests constantly before every agent goes live, and every time there's a new knowledge base that gets updated. We maintain full traceability of reasoning chain from the initial input to the model selection to final functions. And we always use the human-in-the-loop process, so licensed lawyers and legal researchers audit the outputs at all times to provide feedback, to provide correct assignments on any wrong answers. So that expert review keeps us safe and compliant and reliable. And the real impact of Lavo is that we're already transforming legal access in Canada. Currently, we have 200,000 active customers in every single province. Our platform is bilingual, English and French. The way we do it is we do it through a suite of products. One of them, which I showed, is the Legal AI Copilot. We also run a document center with hundreds of lawyer-drafted DIY templates. And we have a 24/7 legal advice line for you to talk to lawyers as a business owner. And on top of that, we have a lawyer locator platform, which provides a patented fixed fee pricing for legal services. And for enterprise customers, we provide AI-driven legal insights for them to make better decisions on their products. None of this would have been possible without Gradient AI. It powers our multi-LLM, RAG, and compliance pipelines. It helped us scale from prototype to production in no time. And it delivers low latency inference, so business owners get real-time answers to their questions. And it allows us to orchestrate multiple agents without the heavy ML ops overhead. Gradient AI has been essential in enabling us to build Lavo as a trusted legal tech platform. And these are some of the tools that we use on the DigitalOcean platform. I couldn't fit all of them here. And thank you.
Thank you, Hovsep. So you saw there how Hovsep is building agents in the legal sector. And this is a sector where you need very, very accurate and precise trust in your agent. And what Hovsep told me earlier as well was that they actually built this on another platform, and it was a lot more effort, a lot more time. But still, when they started using the Gradient platform, they still made that transition across, despite the fact they'd already spent all that time and effort building it somewhere else. And now they're very happy. So that's great to hear. Okay, so building a production-ready agent is a 4-step journey, and today we've talked about how you can build trust in your agents. So building the agent is very quick and easy, but building trust is the part that requires the extra time and the extra steps, and we try to make that as easy as possible. So this is the Gradient AI platform. Again, deploy, test, and build. We've got a number of new features coming up that we've talked about in our keynote today. Though I think one of the most exciting ones is the ADK. So I love the developer-first approach. It's really just going to enable our customers to build agents in the way that they want to build them. So if you want to take a quick picture of this, we have some tutorials, videos from our community. The DigitalOcean community, DigitalOcean is famous because of its community and its tutorials. So there's some amazing stuff on here, some step-by-step processes on how to get started with agents, things like integrating it into Slack, like I spoke about earlier. And we've also got our Gradient SDK here to help you get started. Cool, that is everything from me today. Thank you very much. I'll hand it back to Matt.
Cool, thank you.